Today I have the pleasure of introducing you to the latest reactor being commissioned in our chemical testing laboratories at ILS. This is a polyamide synthesis reactor. Polyamide is better known to most of you as nylon. This reactor is used in particular for testing nylon 11 and nylon 6 syntheses. It's a batch reactor. Polyamide synthesis is a polycondensation reaction done at quite high temperatures. So in this case we have a batch reactor capable of going to 350 degrees Celsius. One of the challenges here was that the client wanted a well-defined start and ending position for a reaction. That meant we had to heat very quickly and cool very rapidly. To do that, we made a reactor which has the heating cartridges built directly into the reactor body. We have an air cooling with a Venturi booster to allow for much more rapid cooling after reaction. The reaction product is removed via a bottom valve. We have a high temperature, high pressure bottom valve here at the bottom. And then you can then remove the polymer melt basically as an extrudate at the bottom into a water trough, which is then chopped into a granulate, which can then be used for mechanical testing afterwards. The nature of this type of polycondensation reaction, as well as one of the main byproducts, is steam. The steam is actually transported via these heat trace lines to back pressure control valves. We have two different back pressure control valves from Badger for this. They're high temperature valves. We need two valves to be able to cover the entire pressure and flow range of interest to this client. We also have two pressure sensors used here to make sure that we have the necessary accuracy over that entire pressure regime of interest to the client. The reactor is also equipped with a high temperature visualization window so that you can actually observe what goes on during reaction, observe how it mixes. Mixing is difficult here because we have a very highly viscous polymer melt. For this we use a Siemens three-phase motor, which is particularly designed to operate at very low stirring rates but have very high torques. We have a special custom magnetic coupling which gives very good sealing but provides high torque as well. And behind this sheet metal cover here we also have a Lorentz torque sensor which provides us with online torque measurement, which gives a very good indication of the degree of polymerization. Last but not least, we condense out the steam formed with the condenser. We then weigh the water produced online, and this water weight measurement gives us a very nice indication of the reaction conversion during the course of the reaction. The reactor is cleaned in the end using monoline ethylene glycol or water, which can be pumped via this high pressure permanent pump here. So we dose the ethylene glycol and the water directly into the reactor hot, and then we can flush it out via the bottom valve and remove any of the remaining polyamide product which is in the reactor. There's also a heated feed vessel here where we can add catalyst or materials at up to high temperatures as well. The entire unit is fully automated. All of the trending functionality has already been pre-programmed as part of the chemical testing here in our labs, where we've been able to work with real reagents and sort out a lot of the bugs, in particular with sealing at these high temperatures and pressures that we encountered. And we look forward to delivering this unit to our clients in around 1 week's time, and hopefully doing follow-up projects with them in the near future, as this is the actual second polyamide unit that we've done with them at the moment.